Okay, good morning students. Now we are going to see about the crystal field theory, shortly we called as CFT. To explain some of the properties like color and magnetic behavior of coordination compounds, crystal field theory arises. Crystal field theory assumes the bond between the ligand and central metal atom is purely ionic. It is an assumption. It is not 100% theoretical. It is an assumption, purely ionic. That let us consider metal is a electron deficient species and ligand is electron rich species. Therefore, how the bond will be formed? There is a strong electrostatic force of attraction between the metal and ligand. The bond will be formed. The ionic bond will be formed. Next, the central metal atom and ligand are charged. If it is charged, they are considered as a point charge. If it is neutral, means they are considered as a electric dipole. They all are the hypothetical, not an 100% truth. Okay. Ligand approach the metal. Already metals having the d orbitals we know. Therefore, what are the d orbitals contain? dxy, dyz and dzx and dx square and then dz square. There is something difference between these three and these two orbitals. How? Let us listen carefully. Here x-axis and then y-axis. Here the lobes are arises in between the axis. Here the lobes arises in between the x-axis and then y-axis. Here the lobes arises in between z-axis and then y-axis. Here the lobe arises is in between x and then z-axis. And here the lobes arises along the axis x and y. The lobes arises along the axis. Here also the lobe arises along the z-axis. Therefore, this three is differ from this two. Among the 5 orientation, just we split 3 plus 2. Next, if the ligand approaches the metal, we are going to see for the octahedral field. Octahedral means there is a 6 ligands, you know. Octahedral means 6. Okay. Let us consider the metal is in the center place. Let me draw the axis. Axis is my plus x minus x plus y minus y, and then these are a degenerate axis. Therefore, ligand approaches 6 ligand. L1, ligand 1, ligand 2, ligand 3, ligand 4, ligand 5 and then ligand 6. This is minus plus z minus z. 6 ligand approaches the 6 axis plus x minus x plus y minus y plus z and then minus z. 6 ligand approaches this 6 axis. As soon as the ligand approaches the metal, it forms a spherical field like this. It forms a spherical field, spherical atmosphere around the metals. Metal is in the center place. Therefore, whenever the ligand approaches the central metal, the ligand arises the spherical field of atmosphere around the metals. Therefore, what happened? The orbitals present in metal have a strong repulsive force because metals also consist of electrons. Here ligand also electrons. Therefore, this negative charge and then negative electrons in the ligand also negative. Therefore, there is a strong force of repulsive force. Next, there is a 5 degenerate orbital xy and then what are 5 degenerate orbital? dxy, dyz and then dxz, dx square minus y square and then dz square. 5 degenerate orbital. Here, because of this, they are degenerate. Degenerate means its energy slightly increases. Then here we call this as a body center. Why in body center we assume that there is an average energy in the spherical field because of the negative energy. A negative energy comes from the electrons. Okay. Now, because when ligand approaches in the orbital along the axis split up into 2. We have dxy, dyz and dxz. In top, dx square minus y square dz square. Listen carefully. We call this splitting as a crystal field splitting. We call these two splitting is called as a crystal field splitting. And one more point. The orbital along the axis. What are they? The orbital along the axis. Here it is. The orbital along the axis experience a strong, the orbit along the axis experience a strong repulsive force than the orbitals along with the lobes, in between the lobes. Therefore, it experiences a high repulsive force than this. That means x square minus y square and dz square express a high repulsive force among this. Therefore, among this 5 degenerate orbitals, 5. Among this 5, how many orbitals is there? 5 orbitals against 3. Against 3 means these 3. Against 3. Among the 5 degenerate orbitals, against 3, it will increase. So, therefore, plus 3 by 5. Crystal field splitting is called energy is denoted by a symbol delta. We are seeing for the octahedral complex, so we put the symbol O. Delta refers to crystal field splitting, O refers to octahedral complex. And then here, what happened? Energy will decreases, repulsive force will decreases. Therefore, among the 5 degenerate orbital, against 2, the energy is decreases. Therefore, minus 2 by 5. And crystal field splitting is denoted as a symbol delta, and we are seeing for the octahedral complex, so we denoted symbol O. And then we call this place as a D2G, triplet degenerate, and this is called as a doublet, EG called as the doublet degenerate. This 2 is called as a doublet. Double. Here the 5 orbitals are split into 3 plus 2. This 2 is called as the doublet degenerated, symbol denoted by a symbol EG. These 3 called as the triplet degenerate, denoted by a symbol D2G. And then this plus, the energy will increases in this area. So plus among the 5 orbitals and against 3. Therefore 3 by 5. Here the energy is decreases among the 5 against 2. Therefore minus 2 by 5. O refers to octahedral and D. Okay. Up to this, there is no formation of these complexes. Ligand approaches the metal, then charge in this positive in the metal and negative in the ligand. There is a negative charge in the ligand. There is a force of attraction, then energy will decrease. Because of the energy decreases, the complex will be formed. I think students, you may be clear in this. Okay, octahedral complex. Next, we are going to see the tetrahedral complex. Let us consider tetrahedral complex. The metal is present at the center. This is a tetrahedral structures, and as it is